Hello, yes. We welcome you back to PSSB, Physical Sciences Silver Bullet. Yeah, today we are going to look at some questions from the topic acids and bases. Okay, it's me, Richard, and we thank you for subscribing. Our pledge to you is that you will not regret. We fail, and we believe that we are simply the best. We are learning the dynamics of online presentation. It doesn't come easily, but we will be there. We want you to stick with us. Okay, let us look at the question here today. The first part says, using equations, explain what happens during auto-ionization of water. Okay, this one is a part we have to know. Okay, auto-ionization of water. What actually happens? What happens during auto-ionization of water is that you have two water molecules reacting with each other. Now, I want you to know that whenever we are doing these equilibriums of acids and bases, we use Lorey-Bronsted idea. What does it say? It says that an acid is a proton donor and a base is a proton acceptor. So when we look at this scenario, what actually happens is that one water molecule acts as an acid and the other one acts as the base. So the one which acts as the acid donates a proton to the other. So when this one receives a proton, what happens? It becomes an hydronium ion. And when after this one losing a proton, what remains behind is the hydroxide ion. So simply, this is what happens during auto-ionization of water. Okay. Next question. Yeah, then comes this question. It says, a small amount of hydrochloric acid is added to the distilled water at 25 degrees Celsius. And the question says, state what happens to Kw. Now, Kw is ionization constant of water. Okay, let us first of all explain how it comes about. Okay, when you look at our equilibrium, this initial equilibrium, there's something you have to know, that water is so weakly ionized. So if it's weakly ionized, it means that the amount of hydronium ions and hydroxide ions are very few. So under that circumstance, when you come to write the ionization constant of water, remember it's the same as the Kc, the normal Kc we know. What do we do? Remember, it's supposed to be the product of the concentration of the products. So this is what we have. And we're supposed to put it under reactants. But I want you to, like we said, water is so weakly ionized that it almost remains unchanged. So under that circumstance, because water does not undergo a change, we don't put it in our equilibrium. So this happens to be our ionization constant, the expression for ionization constant of water. It is very weak, the value is very, very small. Then we come to answer the question. What does the question say? That we said HCl was added. Yes. And what happens to Kw? Addition of HCl or addition of hydrochloric acid, this is what it does. It increases the amount of hydronium ions. But in whatever we do, there's something you have to know, that the water ionization constant remains constant. So if it remains constant and this one has increased, what happens? The hydroxide ions will decrease to maintain Kw constant. So what happens? Okay, what happens is that hydronium ions will increase and hydroxide ions will decrease. So that's what we have. All these questions have been answered. Like I said, when you add HCl, the concentration of hydronium ions increase, the concentration of hydroxide ions decrease to maintain Kw constant. Yes, then comes this question. It says that a solution of unknown monoprotic acid has concentration of 0.0 moles per cubic decimeter and the pH of 3. So the question says, prove through calculation whether the acid is weak or strong. Now, when a question comes like this one, there's something you have to know. Okay, first of all, what is a strong acid? Is the one which is completely ionized. What does that mean? That if the acid is strong, the concentration of the hydronium ion must be equal to the concentration of the acid. And if the acid is weak, it means that the concentration of hydronium ion are supposed to be less compared to the concentration of the acid. Okay, how can we put that one? Okay, let us look at here. If it's weak, concentration of hydronium ion is supposed to be less than concentration of the acid. If it is strong, the concentration of hydronium ion must be equal to the concentration of the acid. So this is what we are supposed to prove. So how do you do that? What we do is simply we get our pH. pH is reflective of the number of hydronium ions in the solution. So you write the equation. What does it say? pH is equal to negative log hydronium ion concentration. And from here, we know our pH has 3. And you have negative log hydronium ion concentration. So from here, we can just press the calculator and get the hydronium ion concentration. So we are going to get the hydronium ion concentration as, let us find out. So this is what we get after computation. What we have here from our pH, the concentration of hydronium ion in the solution is 0.001 moles per cubic decimeter. Now you come and assess, is it strong or weak? From what we see here, we have our hydronium concentration, and you have the concentration of the acid. What do we notice? The concentration of the hydronium ions is far less compared to the concentration of the acid. Remember, they said the acid is monoprotic. 1 mole of the acid releases 1 mole of the hydronium concentration. So what do we say here? The conclusion is there. It is here. What is it? It is a weak acid. Thanks very much. We are going to cut this video here. We don't want to produce long videos. The channel is PSSB, and it's me, Richard. Don't forget to subscribe, and if you have, we thank you for that. Okay, see you in the next video.